Since I started programming in C, it has been a lifelong goal for me to contribute to the Linux kernel, since it's the biggest, most challenging, and arguably most successful open source project in the world. It has thousands of contributors per release, where a big percentage of contributors work full-time on the kernel. This makes core parts of the kernel have extremely high code quality, but code quality depends on the subsystem you're working on and how well maintained it is. For those who don't know, the kernel is divided per feature type, aka subsystem, and each feature type that gets big enough becomes a subsystem. Each has 1 to 2 maintainers and a bunch of reviewers. Most core subsystems are S to A tier in terms of code quality, but drivers on average are lower quality. This actually is the place where most of the code lives. Just so you can imagine, a single driver like AMD Radeon contains 5 million lines of code, and each driver group has its own subsystem and has different code quality which depends on the maintainers and vendors. Among all of these, the lowest quality ones live in staging, which contains unmaintained and low quality drivers for all subsystems. This usually need big changes for promotion as well as documentation and testing. Knowing this, you can imagine that the lower code quality, the easier it is to find stuff to contribute to. Quick reminder that if this video is too fast for you, it is also in an article form in my blog, link in the description. Starting by contributing to the core parts of the kernel is almost impossible, because you most likely don't know how they work. A lot of people recommend starting to contribute by adding or changing documentation, but the reality is that to write good documentation, you must understand the feature/driver you're documenting, which is pretty hard as a beginner. In my opinion, the best way to start is by doing janitor work, where you basically clean up unmaintained code. The reason why it's a great way to introduce yourself into the kernel is because you usually don't need much context on what you're changing. A list of things you can look for are removing unused dependencies, using guards for locking or RAII for memory management, moving to modern APIs, and static analyzer warnings as well as errors. These are all mechanical changes that will teach you the workflow. In my case, the first contribution I made was pretty simple. In the subsystem I wanted to contribute to, I saw they were migrating from the unsafe function sprintf to sysfs emit, so I made the change where these functions were being used and set the patch to the mailing list. For those who don't know, the Linux kernel predates GitHub, since Linus created Git himself, and at the time a lot of communication happened through mailing lists. So to send your commits, you format them into patches and send them through email with Git. Yes, Git can send emails. Before sending a patch, you're supposed to check with a script who are the maintainers and reviewers of a file. And with it, you can send it to the maintainers and CC the rest of the reviewers. At the time I copied all of them and sent them as shown in the script, but accidentally added nonsense. I even sent it to myself and other invalid emails. So I quickly sent the v2 of the patch, and after 2 hours I got a response from a very active reviewer. He kindly advised me on how I should format my description and my code, to which I followed his feedback and created b3 and sent it. And here I made yet another mistake, since I resent the patch even though all those changes could have been applied manually by the maintainer. Then around 2 weeks later I received a message from the maintainer saying he merged my patch and I was welcomed to the community warmly. Here I learned the workflow for sending a patch, responding to feedback, and resending subsequent versions, and also learned not to add noise to the mailing list, since maintainers have huge backlogs and are usually very busy. After my first patch, I wanted to tackle something more meaningful, but for that I needed to understand the drivers better and the different APIs for the kernel. For this, I read the LDD3, which goes over the core driver API and helps you understand how everything connects. This book is pretty old, but the fundamentals of the API have not changed much. Then I learned the abstractions of my subsystem of choice, since pretty much every subsystem will have its own abstraction over the core driver API, which makes it a lot easier to write drivers. Then I started to read the mailing list every day to see what types of changes people were making and what was left to do. And after digging for a while, I found someone trying to fix a to-do, but their patch was not being accepted because other changes were expected instead. So I decided to take that staging driver and fix that to-do, plus modernize it. When making big changes, you're usually expected to have the hardware to test devices you're writing drivers for. But if you set up a VM and make sure to test your changes thoughtfully, then maintainers will usually be okay with it. Just never lie about having the hardware. If you find it interesting and want to know what you need to learn to make your first Linux kernel contribution, here are a list of things you need to know. You should be familiar with C and know how macros, gotos, and some GNU extensions work, since they're used heavily throughout the codebase. Apart from basic Git knowledge, you should set up your Git mail and learn how to send patches. And finally, learn to use these 2 kernel scripts, which will help you check style guides for your code and get the maintainers you need to send your patches to, as well as some basic make experience to be able to build the kernel, your changes, and check for errors. As for advanced material, after you make some contributions and read the docs, you'll have a pretty good idea of what you need to learn, like static analysis tools, using before for sending your patches, Kemu for testing and stubbing, and GDB for debugging stuff. What I want you to take away from this video is that you don't need to be a genius to contribute to the Linux kernel, nor have huge amounts of knowledge. I might also make another video on my second channel showing my workflow to find something to contribute and creating the patch manually, so let me know if you're interested. Anyways, this was all for the video. Huge thanks to all my supporters, and consider supporting the channel if you want to see more of this type of content. See you later.